Right, chaps, we're live, laughing about something else. Welcome everyone to this last Facebook Live with our expert of the year. We've obviously had some really great sessions over the year, and we intend to carry these on into next year where we can, and bring some of the people involved and talk about some other stuff, other stuff that helps promote energy efficiency on heating systems now. So tonight we're joined by Richard and Kim. They can do a really quick introduction if they want now, because a lot of you will have seen them before, but go Richard.
I'm Richard Burrows. I'm from 𝗵𝗲 Plumbing Heating Supplies. I'm the director. Really enjoyed the sessions over this year, and hopefully more next year. Yeah, I think we've got some good things planned in store next year. So with Drayton, so that'll be good. And yeah, really enjoyed the sessions this year. So.
Cool, thank you. Kim?
Yeah, you may know me. I'm the guy that runs the Heating Academy in Northampton. Do it in my spare time now that I'm retired. I do it because I love doing it. More of a hobby than a job. And yeah, exciting stuff coming from Drayton this year. And be nice to see you come down and have a couple of days down here and immerse yourselves in the wet stuff for a couple of days. See what you can suss out.
Sounds good. Sounds good. So tonight we're going to talk generally about improving efficiency with heating controls, and we're going to talk a little bit about flow temperatures and the different ways of getting that maximum efficiency out of your heating system today without going and spending a fortune and changing systems and then heat pumps and all of that sort of stuff. So I don't know who wants to start, but what's the best way to maximize your efficiency with, let's start with smart controls. Let's talk a bit about smart controls.
Well, I think really just before we start on smart controls, we need to really emphasize why we need smart controls. So we need these controls to get the boiler into condensing mode. That's what they're there for. They're not there so you can change the temperature of your hot water when you're on a beach in Bermuda. They're there so that you can maximize the efficiency of the boiler that you've already got in the house. There are things you can do that before you put your smart stat on, but certainly a smart stat will help it be more efficient. But it's all about trying to get the boiler in condenser mode, getting that return temperature down as low as you possibly can. Sorry, Rich, I didn't mean to steal your thunder there, mate. Go for it.
No thunder's been stolen, mate. So yeah, I mean, the whole smart control thing, as Kimbo said, so there's lots of smart controls on the market, but there's a big variation of smart controls, and that's one thing you've really got to be aware of, is that, although you might have an app with it and it might be a thermostat, there's a real variation of smart controls on the market. So the best ones on the market, obviously including Drayton's 𝗻𝗲𝗁, and also the Digistat as well, is if they're an algorithmic smart control. So what I mean by that, they're either TPI controlled or they're open therm controlled. Then ultimately those two things are going to be the best kind of controls to save energy and money. So if you review some of the testing data that we did up at Salford in 2021 with regards to smart controls themselves. So actually what we were comparing there was, when I talk about a smart control, I'm really talking about what we call a class 5. Not V, it's a class 5 control or a class 6 control, which it basically defines the control that it can be a modulation type control with a modulation boiler. So that's either load compensation or weather compensation, but ultimately they're the two main key smart controls, if you can get them, that will make the biggest difference to energy savings in yours or your customer's property. And the way they do that is they modulate the flow temperature to the given demand that's on the thermostat. So basically the thermostat looks at the demand in the property, and then it then translates that data to a flow temperature on the boiler. That's load compensation. Then weather compensation just uses the outside temperature and sometimes a bit of the inside temperature to then modulate the flow temperature again. But either way, they have a real impact on saving energy and money, because they're always getting the boiler to run at the most efficient point. And then if like the TPI controls, so then if we just come back from that class 5 to that class 4 control, then we're talking about TPI controls, and those controls on-off cycle the boiler. So not quite as nice a control as the modulation control, but ultimately what they generally tend to do is they keep the boiler in condensing mode more often, And the reason they do that is because when the boiler, even if it's running at, you know, and I'm gonna dare to say this, even if it's running at 80 degrees Celsius, if you were to put a TPI control on it, some of the Salford test data showed that actually when it goes into TPI mode, which is basically the proportional amount of energy it uses. So if we take a gas boiler, for instance, within a 10-minute cycle window, that boiler might only be on for 5, say it's oversized and there's not that energy requirement in the property, that boiler might only be on for 5 minutes or 3 minutes or 2 minutes of that 10-minute window. So by only being on 2 minutes and being off for instance, for 8 minutes, while that system's cooled down over that 8-minute period, the next time the boiler fires, it actually fires into condensing mode because the actual flow temperature has dropped off to a certain point. So that's keeping the boiler obviously in condensing mode more often. It's not as, I don't prefer it, but ultimately if you've got an on-off, so a clicky stat on the wall, and you replace that with a TPI class 4 control, you will actually, it was about 12%. So certainly not to be sniffed at. And the way it does that is obviously turning the boiler off for a period of time. The boiler goes cool, the radiators go cool, comes back on again, but normally comes back on in condensing mode. So that's kind of where it gets that energy and extra benefit effect. And also they're normally more accurate. So when you're replacing your clicky stat, which probably isn't, I can tell you now, it isn't accurate. So when you replace that with a digital stat, which is then accurate to 0.5 degrees Celsius, then you're going to actually have a really accurate air temperature in the reference room that you're in, and that's where you save energy and money again. So those are sort of the key things, you know.
Could you just explain the difference between a basic clicky on-off stat and a TPI stat as well?
Yeah, so basically a clicky on-off stat. So if we talk about the better clicky on-off stats, so the ones with what we call an anticipator inside it. So the way they work is you set them to a temperature. Normally they've got a liquid like propane expansion bellows inside them. And as the temperature in the room increases, the expansion bellows expands and basically it clicks it off. So where you've set it to and where the bellow position expands to, clicks off the stat, then that's actually where it will go off. But normally that off position will normally result in an overshoot, even with the best anticipators in the world, which is basically a little heater inside the thermostat, which when the on demand of the thermostat commences, basically starts heating up the internals of the thermostat just to try and prevent that overshoot going too high. And basically they're just clicking on and off. So what you end up with is this hysteresis. So you end up with this sine wave curve. If you've ever seen like a 230 volt AC system, electrical system, and you ever look at the sine wave, it's basically this up and down graphed out. It's just this up and down graph. And you get the same with heating. What you get on the thermostat is it will heat, say you set it at 19 degrees, it will typically hit 21 degrees or higher, and then it will drop. And as it's gone below the 19, it kicks back in again, but it's normally too late. And then it will drop, you know, as low as 18 degrees before it will then come back up again. And the problem with that is obviously you've got these big temperature swings, which what most customers will do is actually elevate the temperature of their thermostat to counteract that colder drop-off effect. So actually then what it does is overheats the room because they up the thermostat, it overheats the room and then drops down to their minimum requirement, but always overheats before dropping down again. And that's where your energy wastage comes in. And that's the biggest difference between your on-off and your time proportional thermostats. Is what happens with the time proportional is as it's coming up to hit that set point demand, it will hit it, slightly overshoot, but once it's overshot and realized how much it's overshot by, it will do a very quick calculation, which then allows it to have a very minimal hysteresis around your set point, which then is a lot more accurate and you don't end up wasting as much energy that way. So those are your key differences. But your on-off thermostats out there, they're wasting a load of energy, and I can't explain it, but circa in the real sense, and you know, it's
Richard,
really cool. Thermostat. You can go to that net. Oh, have I gone wrong?
You've gone wrong.
That's always rubbish, isn't it?
Right at the end.
Can you hear me right?
Right at the end.
Yeah, you're all right. Am I back?
You're back. You're back. Bit delayed, but you're back.
Yeah, I'm back. Good. Sorry about that, everyone. Yeah. So, Heart of Mid-Wales. So you can't, we're lucky with, I'll have to get the sheep out there on it, on the old spinning wheel to get it up and get running again. But yeah, that hysteresis is really important. So the Kimbo's lost it. The least we can get that hysteresis working around set point, the better, because that's ultimately, if you get that overshoot, you're wasting energy. So we don't want to waste any energy. So that's what upgrading controls is all about. Actually, I had an interesting bit of a conversation with Alan Hart this week. He's on all the social media channels. Everyone knows Alan Hart, but I think something actually clicked with him this week, and that was actually what I was talking about, the difference between a Class 1 and a Class 5 thermostat, and the biggest difference in energy savings there are to be had with that. And I think it was the first time he'd actually read the report from Salford that I was involved in, and actually understood what we were trying to get across. So, I mean, he's been promoting Class 5 thermostats all week, which is brilliant. But, you just got to understand what you're trying to achieve with a smart thermostat and go from there, really. But it's part of the puzzle. It's not all the puzzle, it's part of the puzzle, but it's a really quick way, because you can go out there, spend less than £100 and get a TPI, a Class 4 TPI thermostat, which will save, 12%. So it's a really great measure to do if your customer's looking for a very quick fix, to try and save some money. And then I think leading on to quick fixes, maybe we've gone to flow temperatures, because that's pretty much directly proportionally resulted with that. So I don't know if Kimbo wants to kick off a little bit, because ultimately,
so the room stat essentially is controlling the temperature in the room, not necessarily how the heat's getting into the room to be controlled. So we can send the heat into the room at 80 degrees, and our room stat will do its best to try and control it. Or we can send it in at much lower temperatures, and our room stat will also try to control the room temperature. Rich has sort of been talking about system efficiencies of not wasting energy in the room. We can also look at boiler efficiencies by trying to keep the amount of energy the boiler isn't wasting by keeping the boiler in condensing mode. I know I keep on about this, but if you walk past a £10 note on the pavement, it's free. You just stop and pick it up and say, "Oh, bloody hell, bit of a result there." But we've got these £10 notes that are just free for us to grab in the boiler every day. Well, maybe not every day, but all the time. There's free energy there that we can just take, and yet for whatever reason we just don't. And I think the reason is because we've been used to gas at 3p a unit and 2p a unit forever. Our gas bills have been sort of more or less the same forever. I know British Gas for advertising that, swap one of them old iron boilers for a new one, you'd save 40%. Well, not many people saved a great deal at all, really, because most of these new boilers are put in and they don't condense. So there isn't any savings there at all. And I think a lot of people just assume that because it says on the side of the box, it's 96 or 98 or 92, whatever percent efficient, they take it on the chin and say, well, there you go, there's a 98% efficient boiler. It says so on the box, look. What it doesn't say, of course, is that as engineers and installers, we nearly have to tweak a few things and understand how condensing works and how we're going to get those return temperatures down to achieve this extra sort of up to 10% that's free. And it is free. So if I can do my bit at the boiler end and save, 10% there, and Richard can do his bit for £100 at the room end, and of course his more complex controls will actually do both. The controller will control the boiler and the room temperature. Is that class 6? They're class 5 and class 6, aren't they? Those one, Rich?
Yeah, 5 and 6. Yeah.
5 and 6. So it's the clicky stats where the boiler does its own thing, and then the clicky stat tries to help in the room. So if you've got clicky stats, we need to manually try and get our boilers more efficient, and the only way we can do that is by manually turning down the flow temperature, which in turn turns down the return temperature, which in turn gets us more into condensing mode. The thing I want to stress here that this only relates to combi boilers at the moment and gas boilers. So we're not talking about oil here at all. We're just talking about combi gas boilers, which are the vast majority of the boilers we've got in the UK. So if you've got a clicky switch, obviously the first thing to do would be to upgrade that. But if not, and as well, turn the flow temperature down. Now, the worst thing that's going to happen is that the temperature is going to be so low that your room isn't going to get warm. Well, if that happens, just turn the flow temperature up a bit. and try and see what the lowest is that you can have whilst keeping yourself warm. I know it's a little bit of a pain. As you can imagine, I try all sorts of things here, and I've got all sorts of stats. We've got 𝗲𝗍𝗻 and all sorts, and I'm always trying to trip everything up and see if we can, squeeze a little bit more out of it. And I'm always trying to lower my set temperature all the time, get it as low as I can. I mean, my radiators are warm, but only just. Even today, we're about 5 degrees today. My rads are, I should have looked before I started tonight, but my rads are cool. And yet my house is toasty at 21 degrees. And my flow temperature is probably not much over 40, 45 maybe. Now, you can't get the 20 DT, I don't think. As much as I try hard, it's difficult to get that on the boiler. But certainly it means that the whole boiler end of the system is being as efficient as it can before it hands its energy over to the system. Then we look at making the system efficient. And similarly, people about system efficiency, what does it really mean? Well, if you've got your window open, your system isn't very efficient. If we've got losses that we can get, that we can find a way around not losing, more insulation, that sort of thing. If we can control the flow going into the radiators, so that we've only got the right amount of energy going into each room. I mean, I often say that at the beginning of my training days. If this room we were in today, this training room, if it had a heat loss of say 1 kilowatt at -4, and we could work out how much energy we needed to supply, what flow rate do I need to supply 1 kilowatt of energy? It's about 43 litres an hour if anybody's interested. But if we could just put that 43 litres an hour in, then the room would reach set point and we wouldn't be wasting any energy. We wouldn't need a TRV in theory, because we would only be giving it the right amount of energy. And then if we use class 4 and class 5 controls, Ritchie's controls, well, not Ritchie's controls, but controls that Ritchie's been talking about, would then pick up the baton and say, right, okay, with this correct amount of energy, I will now make sure that as the temperature outside increases or change, I will reduce somehow the flow temperature or the flow rate going into the room to maintain the set point. And this is where these pressure independent valves and understanding flow rates and all that sort of stuff comes really important. People think it's really complicated. It's not. It's really simple, really. Very simple maths formulas, and you can work it out on the back of a fag packet, really. And the difference when you start tweaking all these things is amazing. When you get your system up and efficient, and your boiler up and efficient, and then suddenly you can genuinely get sort of 25% of efficiency, and that's a tremendous amount of saving, not individually financially, but if you look at sort of 20 odd million gas-fired houses that we've got in the UK, if you could do something along those lines in all of those properties, think how much energy we could save.
We are. I mean, the Nesta campaign has done amazingly well, hasn't it? I mean, for what it is, I mean, it was benchmark on the Salford testing this year, and I mean, it's there's a 23% saving. So from 80/50 was a 23% saving. So if you can get your flow temperature from 80 to 50, and that was we tested with the key thing to remember in this scenario is it was just a flow temperature test, okay? And that was using a class 1 control. So we didn't upgrade the controls in this situation. We literally just adjusted the flow temperature from 80 to 50 degrees. So at 50 degrees, we were struggling, I'm not going to lie, we were struggling to achieve target set point temperature. But you've got to bear in mind the target set point temperature of the living room in the Salford tests was 21 degrees Celsius. Now, we're already telling people to reduce your room stat temperature down to 19 anyway, and it achieved that at 50 degrees flow temperature. So we still achieved 19 degrees Celsius. So do you know what I mean? So if you're willing to, if you're aiming to turn your thermostat down anyway, and you're able to reduce your flow temperature, the two combined had a really massive effect on how much energy you can save. So 23% saving is possible, and that was so that some of the system design is quite key here. So this was a system that was designed for 50/70 or 70/50, whichever way around you want to do it. Okay, so the actual heating system was designed for 70/50. We ran it at the average external air temperature. Okay, so although it was designed for -3, so what I'm not saying is at -3 you would need that 70-degree flow temperature. There's no question about that. So you would need that. But at average external air temperature, like Kim said, today it's 5 degrees outside, okay? we're +8 on our design temperature. So although it's bloody cold out there, we're +8. At +8 degrees Celsius, a 55 or 60 degree flow temperature will easily satisfy that. And this is what people just don't realize in our industry, is the fact that they think because you've designed at 70, you've got to be 70 all the time. That's not true. You can vary that flow temperature, and that's what weather compensation and load compensation is all about, is varying that flow temperature based on the actual heat loss of the property. So the key thing about class 5 controls and flow temperature is that class 5 controls do very, very much the same to weather compensation, but class 5 controls are working out very cleverly, or the clever ones do, not all of them do, but the very clever ones actually work out how much heat loss is being lost out of your wall, okay? So it's watching that, the thermostat's actually watching that and recording that heat, that, what do they call it? I always forget the word. All the scientists use it, but basically it's the energy that's basically lost to atmosphere through your walls. And when that happens, it's recording the rate that's changing, and it can actually work out how much heat loss is happening in that room. So then it knows how much it needs to put in to mitigate that loss, okay? And then, but one thing it is doing is assuming that same heat loss is happening throughout the property. So what you've got to be really careful with thermostats and your positioning of the thermostats is that you don't reference that room that has a less heat loss than the rest of the house, because what you'll end up doing is having a nice warm room there but colder rest of the house. So what you've always got to make sure is that your thermostat is always well positioned, and that's really, really key, is that you always reference from a room, ideally the room you live in, but make sure that that room isn't the one with the least heat loss in the entire property. Otherwise you could come into problems if you're just using a single zone thermostat. That's kind of why I like the multi-zone systems and what we call the class 8 thermostat systems, which is your multi-zoning, but also with modulation technology. So that's your WISER with OpenTherm, basically. So a full WISER system with all the rad TRVs. That's a class 8, when it's using OpenTherm and on a modulation boiler, that's a class 8 control. And that's then the best of all worlds, because if you have got that difference of heat loss in different parts of the property, the one that's got the greatest heat loss always wins. So that way, that one's always your biggest demand factor on the system. So when it's calling for the OpenTherm demand, say it's calling for, I don't know, a 55 degree flow temperature, the rest of the property might have been able to do maybe a 45 degree flow temperature, but this particular room's causing it to be, it's 55, because the problem is with most systems out there, they're not designed perfectly. They're not designed for the heat emitters to perfectly replace the energy that's being lost. All the rooms are oversized, the radiators are actually oversized to the rooms, and then we have a load of problems. And the systems like this with a TRVs in each room, they actually calculate out how much heat loss is per the room. And then the one that's got the greatest heat loss, that's the one that then tells the boiler to go the correct flow temperature for that greatest heat loss. And what the other TRVs do is they'll modulate their positions down to not allow as much energy into those rooms that have got the less heat loss. And that's how it then saves money on the entire system. And that's why I really like that kind of system. Not in every scenario, because with the heat pumps, we have got to be a little bit careful what we do there with our design and how much flow we have and this, that, and the other. But with a gas boiler, if you've got gas or oil boiler, I can't think of a better way of controlling a heating system than actually have a room-by-room control. Some people say it's over complex, but to me, I've seen some really big savings, like 40% and more over my time, and that is testament to that room-by-room accuracy and that not wasting heat in certain rooms and areas, because every area is different. You can sit down and you can calculate it all out and do what you want, but someone's always thrown a curveball in there, because one of the rooms where you think the wall's not insulated will have insulation in it, or the wall you think has got insulation in it has not got insulation in it. So we can't be perfect as engineers when we do these calculations and we do the heat loss calcs and we work it all out. We can't be perfect. And these types of controls, you can pretty much throw them into a system, and as long as that system's half balanced, then they'll perform miracles on that system without having to do too much work. But ultimately, design is the best way. But in this scenario, we're kind of in with massive amounts of energy wastage. We're in a obviously energy crisis. All these kind of things come into their own just to try and mitigate some of the issues we've got. But, you know, and they do that automatically. Like I said, a Class 8 control automatically adjusts the flow temperature at the boiler, and it then references each and every room that goes around the system to get the accurate flow temperature. And that, you know, I can't think of many systems that will give you that kind of energy saving. But
yeah.
yeah.
I'll tell you what, Rich, they're that good. You've actually forgotten one feature, and it's probably my favourite feature. So I've got I've had 𝗍𝗲 and 𝗁𝗲, and I've got 𝗁𝗲 at the moment. And I'd like to say that I upgraded to 𝗁𝗲. I should say that on this program. But one of the features that I see, and as I've been learning, well, 𝗁𝗲 hasn't been in that long, and I'm running around with laptops and temperature gauges and all sorts of stuff. So I'm a bit sad like that. One of the things that I've noticed is that on my side of the bed, the radiator's on my side of the bed, and the 𝗁𝗲 head is at my end of the radiator. Now the 𝗁𝗲 heads are nothing like as noisy as the old Evo home heads. They were like an alarm clock when they started chuntering away. But even now with the 𝗁𝗲, I can hear it click. I can look at the clock, and I've got a rough idea how warm it is or cold it is outside. Because predictive start, this stuff is that clever that now you no longer say, oh, I'll switch my heating on at 8 or 7 o'clock to get it ready for 7:30. What it will do is you just say to these controls, right, at 7 o'clock, I want this room to be at 21 degrees. And what it will do, depending on what type of control it is with outside sensors or whatever, it will know on a cold day it needs to start a bit earlier, and on a warm day it needs to start a bit later. And it also is affected by flow temperature, because the heat up time is quicker. When I'm trying to explain, you know, low temperature heating and getting the flows right and all the rest of that stuff, we've been used to for 30 years. After we fitted a new system, you know, you fire the boiler up and then it's a mad rush to get to the first radiator before it's hot. You know, sometimes, you know, you walk straight from the boiler to the first rad in the living room or whatever, and it's already getting hot because there's so much more flow in there than we need. It's all so hot. We've got an unregulated boiler that you can't range rate, so there's perhaps 25-30 kilowatts giving it yeehaw down the pipe, whizzing around there at 100 miles an hour. All of that now stops when you start doing things correctly, and you've only got the right amount of flow going to the right place at the appropriate temperature. Everything takes a lot longer. And so this predictive start, or auto start, various names it's got, I think, this predictive start is why we've got predictive start. That's how I've interpreted it. So that as an operator, we don't need to worry about who cares what time it starts, as long as it's 21 degrees, it's 7:30 or whatever. And if it takes an hour to warm up, you know, because it's nice, and so who cares? You know, it's not going to take an hour to warm up, but you know, we don't have to have this race. I know a lot of people defend, or you know, my customers want a quick reheat time. Well, actually, they don't anymore. They just want cheap heating. I don't want to pay more money, you know, so that I can switch my boiler on 5 minutes later in the morning. I want it to, you know, as cost effective as I can. And if we go back to you know, this excess flow, one of the other big problems that we take on the chin is, you know, the ERP pumps. Oh, ERP pumps are fully automatic. They're not. You know, they're only fully automatic. They only do something automatically after you've set it in the appropriate place. If we just leave the pump how it comes out of the box, and invariably it's somewhere set between 80 and 100%, the pump pressure, there's far, far, far more pump pressure coming out the pump than the system ever needs. And so consequently, we've got 2, 3, maybe even 4 times the flow rates going through the system that we don't need. I mean, have you ever been anywhere and seen a 3-speed pump that's not on speed 3? You know, yep. When in doubt, crank it up to max, rip the knob off, and then you don't get any callbacks. But it doesn't mean it's right. And so we need to understand that if we fourfold the flow rate, or we double the flow rate through the system and through the boiler, that's going to half the DT. And so our DT that we want, and we're trying to get to 20 to get our boiler in condensing mode, to get the return temperature down, that's all lost. And there's nothing we can do about it, because the water's whizzing around there so fast. Nobody knows to go into the parameters and change the pump pressure. And people don't understand index circuits. So even if they did say, oh, I know I need to change it, they wouldn't know what to change it to. And so there are lots of skills that we've lost over the last, I don't know, 15, 20 years, because everything gets hot. You know, people say, oh, you know, I don't care what you say. My customer's happy. The rads are red hot, and the hot water's, you know, red hot coming out the tap. And that's not what we're all about anymore. That's not what we should be doing. We should be supplying just enough so that everybody's warm, not wasting any of it. You know, while we're heating our water up to 60 degrees, if our showers are only at 40 degrees in the combi, if you only need sort of 40 degrees while we're getting our combis up to 60 degrees, because then we've got to use a load more cold water to blend it down. All sounds a bit crazy. We just need to step out the box a bit and realise that we haven't needed to know this up until very recently. You know, in the last few years, you've had this massive increase of super electronic technology, apps, and all this magic fuzzy software. I mean, I don't even know how fuzzy software works, but it's like magic, you know, and yet we don't use it. I say to my guys, you know, how many of you who uses the 𝗵𝗻 control? And sort of 7 out of 12, oh yeah, I'll use them, I love them. And I say, you know, 𝗵𝗻 control is fantastic. You know, do you wire them up open thermal or no, we don't want to go outside of that comfort zone. And you think, look, if you just
why is that, Kim? Because they don't understand it, or because they don't understand the value?
It's going out of your comfort zone, and I think we've gone through. We went through an early period when we had 15-year-old spotties designing the interface, and it was all very complicated. Push this button and press that 5 times. Once you lost the instructions, that's it. It's like when you bought one of them cheap Casio watches. You ended up only being accurate for 6 months of the year because you needed an instruction book to change it for summertime. And controls went from being on-off switches to these boxes 2 inches square with a tiny little screen on. You know, you need glasses on to read it. There were 5 angry-looking buttons at the bottom. Nobody actually knew. All you wanted to do is to get your bloody heating on. You know, and nobody really knew. You damn press a button and hold it for too long in case it resets something. We've got round all that now. You know, most of the controls that we see, it's the same interface, whether you use on-off clunky control version of it or the open therm version of it. The interface is the same. But the guys won't wire them up open therm because it's still, you know, I'm not quite sure about that. What happens if I get a call back? Not going to know what to do. You know, if the customer's not happy, if it's not getting hot. It's difficult, you know, and I try and say, look, just trust me. Just instead of putting those 2 wires in those 2 bits of the terminal block, put them in these 2 bits of the terminal block. No one will know. Don't even mention it to your customer. You know, because some guys say, "Oh, my customers don't want open therm. They don't want anything." Well, don't tell them. You know, don't tell them. They're never going to know.
The irony is, though, isn't it? The irony is,
you don't say, "I want the latest ECU that gives me the most miles per gallon and the most speed. I want the old one." You're very grateful that the new one's better than the old one. But we seem to have this thing in our industry about, you know, hanging on to the old brigade, hanging on to this old technology. And I don't know how we're going to break the circle. It's trying to get guys not to do S&Y plans. You know, I don't know how we're going to break that circle either. We're getting no help from the government or building regs or anything on that one. I don't know what's going on. Well, I do, but I'm not allowed to do politics tonight, am I? But you know, it's the whole thing is extremely frustrating. People hang on to the old ways of doing stuff because they know it works, and I get that. But you know, how are we going to do this with advertising or education or whatever it takes? But we've got to do it one way or another.
Like I say, on the positive side, this week that with the government obviously endorsing Nesta's policy now for reduction of flow temperatures, which is amazing because you know we never thought in the world of starting this that would happen as quickly as it has, which is amazing. So we're definitely on the right track. And I mean, I just want to pick up on your 2-wire thing with the 2 wires on like an Ideal Logic. It's the same 2 wires they use for on-off switching as they do for open therm. Yeah. So all you're doing is on-off switching the open therm connection, which is crazy because why not just connect open therm to open therm and it'll work, you know, and it'll work a damn sight better than the on-off switching will. But I do get it. I mean, we sell an open therm gateway, and the reason I sell the open therm gateway is because we want to give the installers the ability to actually read what's going on in the open therm connection. Because without that data come, without being able to see that data and what's going on, they are quite difficult to diagnose. It's you need to understand, and fingers crossed going into, like, we're trying to get it up and running for January, February, end of January, beginning of February. We said this for a few months now, but I am working on actually building our training, because we kind of know where we're going now. So we're building our training area now, and hopefully end of January, beginning of February, I'll be able to start bringing people in, teaching them this stuff, and then we can go from there with it all. But it's kind of that education. We're going to do a load behind it going forwards as our business, and just try and educate on just upgrading stuff, why we need to do it, what we're doing wrong, and actually then start getting people in the door just to show them where we are going wrong. Because, like, the whole pump thing, I mean, an interesting one this week. So our unit where we're based at the moment, we have a 54 kilowatt, right? So 54 kilowatt, high level, it's not a Benson unit, it's one of the other ones that's equivalent to it, but commercial warm air unit, right? 54 kilowatts, okay? I've got Drayton Balancing controlling it, okay? And the really interesting thing with this thing, right, is that it's literally, it comes on, right? This 54 kilowatt unit comes on for about a minute, 2 minutes, and then goes off, right? And then stays off for the rest of the 10-minute period that I was talking about earlier, right? And then 8 minutes later, it'll come on again. 2 minutes, it'll go off, right? Okay, so it's compensating the amount of energy going into the building, right? Well, but this week I managed to get, or end of last week actually, and then this week I've been tweaking it. We've been playing with a 𝗺𝗲𝗺𝗃, okay? Because I want to show installers the 𝗺𝗲𝗺𝗃 really is the worst of the worst boilers out there, okay? So if you're going to put a condensing boiler in, right, and you really want to upset your customers, go and fit a 𝗺𝗲𝗺𝗃, okay? Because how are you going to get it to condense? This is what I've been testing this week, right? So if you're gonna really put anything bad in, put that in, because if you really want to upset your customers, do it, okay? Right. So I thought, what I'll do, I'll buy this boiler, install it, and then I can actually test it, and I can actually understand exactly where it's going wrong, okay? So we got this thing on the wall, we got it fired up, and bear in mind, it's a 𝗺𝗲𝗺 9RI, okay? So it's the smallest boiler. I mean, you've got to commend Worcester for making a 9 kilowatt boiler, okay? But basically what it showed, we got this thing up and running with a high level blower, okay? And I got it set up, DT20, and Kim will verify that my DT20 was infallible DT20. So we had it 50, we were running it 50/30, okay, right? So we had 9 kilowatts going into the system. I balanced the pump up, so we got 50/30 across this heat exchanger, okay? So we got that going back to the boiler. I think it's probably the only 𝗺𝗲𝗺𝗃 in the country that's actually condensing, okay? So but the interesting thing about it was the fact that it actually heated our unit, okay? So this thing, right, we've had this 54 kilowatt high level unit, right, which we've been running, and then this 𝗺𝗲𝗺 9RI is actually heating our entire unit. And it just goes to show that the external air temperature has been about 6 to 7, right? But it just goes to show at 6 to 7 degrees external air temperature, all my unit needed was 9 kilowatts to keep it warm. Yeah. And it's a big old place. It's 256 square meters, okay, our place is, right? So it's not small, okay? And, you know, it's old. It's a 1970s building. You know, it's got asbestos roof with very little insulation. It's got solid walls with a tiny piece of insulation in there. And it, you know, if you walked in and you looked round, you would think, you know what, this place is 30 kilowatts. Yeah, you really would. But I haven't sat down and done the maths on it yet, but I can tell you now, this 𝗺𝗺𝗺 9RI was maintaining air temperature in there, bang on the air temperature. And the nice thing was, what happened is, because the 𝗺𝗎𝗇r has been controlling the high level unit, it's been used to this, like, put a load of energy in, oh my God, hit the brakes quick, right? And then, you know what I mean? But it started doing that, and then it realized that, hang on a minute, something's going on here. Something's happened here, so I've got to change what I'm doing. And by yesterday, it had actually modified its algorithm to actually start on-off controlling on a lower kilowatt input. And it's amazing, because these things reprogram themselves. So if anything changes, and like the weather changes, the heat loss changes, any little temperature differences like that. These smart controls actually change what they're doing and recalibrate, and that's the absolute beauty of them. And it was nice to see, because I'm going to start graphing it out the rest of this week, because I've done the baseline tests on what I'm trying to do, and now I'm going to start graphing out. And what I'll do is I'll share it across the groups when I've started doing that, just to show you how little energy you actually need to go into these places to heat them up, how little flow you need, because obviously, you know, if you've got a 9 RI, we only need 9 kilowatts of flow through that system, which was basically pump speed 1. You know, and you know, like Kimbo says, you know, how many places do you go out to? And these places, you know, you try and tell me these places you go out to, they're bigger than 256 square meters, because they're not. Half of them are going to be half of that or less, and we've got these systems, and yet we've got them on pump speed 3. You know, and why is that? You know, there's no rhyme or reason to it. So, you know, and what I want to try and do is just educate around this, show you how to get these really crap boilers, you know, because they've really got nothing on them you can adjust. You can't range rate them, you can't adjust pump overruns, you can't do anything on them. You literally, they're literally as brutal as they come, as dumb as they come. That's what they are. But the difference that if you put a smart control onto something like that, the difference it makes is night and day. And you know, like I said, with adding the flow temperature reduction and everything else, it's brilliant. You know, and what I try on what I want to do is I want to just show how bad it can be and how good it can be, and then the measures you need to do to make it that way. And you know, but just little things like that. You know, it's, you know, with the advanced, like Kim said, with the combi boiler stuff, it's easy. With the system boiler stuff, it's a lot harder to do. But obviously, we want to try. You know, the goal is we want to have system boilers that basically have 2 flow temperatures, and there's loads of them out there at the moment. You know, Alpha, Intergas, Viessmann, Valiant, Worcester do them. They're all over there, but it's just that education around that these boilers can do 2 flow temperatures. They can do modulation controls. You know, all their open therm, and they can do the open therm priority hot water over the open therm connection, because that's ultimately what we want to be doing, is having the most simple controls that we can modify up. But yeah, you know, it's all doable, you know, and we have discussions in our own little groups. And I think before I came along, I think most of the guys in our group thought DT20 was a myth, you know, and it was, you know, or DT20 is not achievable. But, you know, you've got the products there that can do it, like the auto balance TRVs. That's the whole thing about them is actually getting that flow rate correct through the radiators, that you can get that DT20. Because if you go and put them onto, like, I'm telling you now, you try and get an Ideal Logic or a 𝗵𝗲𝗁𝗍 or something like that, right? And you have 6 rads on it, there's no way in hell you're going to balance that system. And something like an auto balance TRV, you put it onto that system, it will balance it up, no problems at all. You know, even with a 6 meter head pump on maximum, you know, you're gonna be able to balance that system, and it's really key. You know, you're never going to get DT20 if you can't balance that system correctly. You're never going to get DT20. You know, even at design conditions, it's not going to achieve it, because if you're using traditional lock shields to balance the radiators down, they're just not good enough. They haven't got what we call the valve authority, which is basically when you're trying to wind that lock shield down on the aperture, they get to that point at which it goes, you wind it a tiny bit, it's off, and you wind it a tiny bit out, and it's too much. You know, and you can't win in that scenario. You need something you can, if you're going to adjust it on a lock shield, you've got to be able to have something that you can adjust. And, you know, a turn only, you know, sort of changes and that's it, you know, but you're never going to get that because there aren't those, you know, TRVs out there. So something like the auto balance TRVs, they're brilliant because they take away all that messing about. They keep the flow proportional through the valve. And, you know, once you've done that, systems are really easy, and you will get those DT20s then really easy. All you need to do is just look at the 2022 Salford tests on the flow temperature reduction. We use the auto balance TRVs there. You can see we got DT20 perfectly. If you look at all the graphings out, so if you look at the 70/50 results, which is where it's important, we got DT20 there, and that was with real and relative ease doing that. And, you know, so it is achievable. You can do this. It's just you've got to have the right tools, got to get the pump speeds right, got to have the right tools in place, got to have the controls on the back end, because ultimately they give you that extra measure. So, you know, it's all right. We can do all the system tweaks in the world, you know, and reduce the flow temperatures, but there's more to have. If you've got the right controls in there, there really is just that much, that bit more to give, you know. And like Kim said, it's those algorithmic days, you know, the days where you've got one day we got -1 or 2, and then the next day it's +6 or +7. You know, on those days, on-off clicky stats are really going to struggle, and flow temperature reduction is going to struggle with that, you know. Where if you've got something that's optimizing that as a smart stat, that's always going to win over that. But I don't know.
I'm going to try and answer. There's a couple of questions come up. There's one that I can definitely answer. We'll just talk about this one. Somebody asked if I use an external weather compensation with 𝗺𝗲𝗁, which also has weather compensation in the software, which takes priority. Okay, so I'm playing with that right at the moment. I've got an intergas which will do which will do weather compensation on its own. So I've been running 𝗺𝗲𝗁 using its weather compensation, or its external Google, wherever it comes from, weather compensation. I interpret that as like a preemptive strike. It's looking ahead at what's going to happen, and it's being proactive. It looks and says it's going to warm up in a minute, so I don't need to be maybe putting any more heat in. But I can say that you can use the boiler's own weather compensation. It all still works absolutely fine. So I am at this very moment, I've switched off the 𝗺𝗲𝗁 weather compensation facility, and I've switched on the intergas facility. Now, what I can't do is, because I don't have the test data that Richard does, I can't notice minuscule differences. What I can say is that it hasn't made any noticeable difference. My radiators are still running cool. What it is doing is that, as you say, on a warmer day, the flow temperature my set point, and I can see that on the boiler, my set point will be a bit lower. And then I am assuming at the moment, because it certainly seems to be working that way, that the 𝗺𝗲𝗁 reacts to the new set point. So one day it will wake up and it'll have the boiler will say, right, mate, today your set point's 72 because it's bloody freezing outside. And as Richard was saying, the next day, if it's maybe, you know, much warmer outside, it'll say, right, okay, your set point today, pal, is only 62 degrees. And 𝗺𝗁𝗺, bless it, is seeming to resolve all that. And like I say, I can't put all the test data on, but it certainly doesn't seem to be causing any problems.
It's what we call TPI hybrid. Sorry? TPI hybrid was what we called it, Kimbo.
Oh, right, okay.
So when we used to do the weather compensation with on-off switching, we used to call it TPI hybrid. So basically, the boiler was doing the weather compensation, but then your controls were doing the on-off switching part. But yeah, what you used to find actually is what we used to find was the TPI aspect would back right off. So where the controls would usually jump in, and they would like, I don't know, I'm going to explain TPI a little bit because I don't think I've explained it very well. TPI basically, if you set it for a gas boiler, okay, so we'll just talk about gas boilers a minute. If we set TPI control for a gas boiler, what we're doing is we're dividing the intelligence of the thermostat into 10-minute windows, okay? So there's, when we talk about 6 cycles per hour with TPI control, what we're actually talking about is 6 cycle windows of 10 minutes, and that makes up your hour, okay? So what the thermostat will then do is work in these 10-minute blocks. And what it does, so as it starts off, it might run the boiler for the entire 10 minutes, okay? So when the system's cold and the thermostat's got to come up to demand, it will run it 10 minutes, 10 minutes, 10 minutes, 10 minutes. As it starts approaching demand and it's going to hit that set point, it will start backing it off. So it will go, okay, well, we're going to hit it at this rate. So what I'm going to do, I'm just going to try 5 minutes out of the 10 minutes and just see what happens. So what happens then is your boiler stays off for 5 minutes, comes back on for 5 minutes. So basically it does 5 minutes, 5 minutes, 5 minutes, 5 minutes, like that. So it's proportional, you know, and then what you're doing, it's a proportion of that 10-minute interval, okay? So, but when the testing I did very early doors, I mean, Christ, must be 12 years ago now, 12, 13 years ago, we were doing TPI hybrids, testing on it. And what we noticed is the TPI aspect backs right off, because actually what we've done is the boiler's actually then adjusting its own flow temperature, and all the controls have got to do is make sure that overshoot doesn't happen. Okay, so instead of actually the controls trying to adjust the flow temperature, if the TPI aspect is still kicking in, so if you're getting this on-off switching of a boiler once you've weather compensated it, then your flow temperature isn't actually cool enough, if you know what I mean. So if you still, so say the weather compensation for that particular day has adjusted it to a 62-degree flow temperature, but the TPI control is still kicking in, so the boiler's still on-off switching on the TPI control, then actually your flow temperature isn't low enough. So you can actually go a bit lower. So you can, if you adjust your weather compensation curve on your boiler and then try it again, ideally what you want is the controls literally not TPIing at all. And that's when you know you've actually got your correct weather compensation curve set. So that was what we defined as TPI hybrid, but basically it was a class 2, because normally they define the sensor on the boiler as a class 2 control, but a class 4 controlling it overall, if you know what I mean. So you had a class 2 weather compensation with a class 4 controller. And they work really well, actually. So all the systems that I did back then and up to now, they're all still going. And, you know, the customers were always happy that the fact that the temperatures were always hit on time, because most of them had what Kim was trying to say earlier is optimum start, which is basically where it works out where you need to start from and then get it to that point. So, you know, that's the general effect of a good smart control. They have optimum start, they have optimum stop, which is also really good. And then if you can then get a weather compensator in on the boiler as well, like Kimbo's done in, you know, when he's put his 𝗻𝗲𝗁 system on his system, and that's really that's kind of the ultimate you can get before then going over to your class 5 and your class 6 controls. And I bet actually if we did a Salford test, there would be very little in between the TPI hybrid control and the class 5 control or the class 6. I bet there'd be hardly anything in it. The only thing you would notice is there would be that TPI switching, so there would be more cycling of the boiler. But ultimately, you know, the actual flow temperatures and everything, they would be, dare I say it actually, because TPI control would actually turn the boiler off for a duration, so the flow temperatures would actually dip and go lower for a little while. TPI hybrid might actually give slightly more energy saving. It's a bit weird how it all works sometimes, but maybe we'll have to test that one day. I don't know. But
so the other question there is does 𝗻𝗲𝗁 now work with 𝗵𝗲𝗁𝗁𝗃 on open? Now I personally can't answer that, but what is sad is that question arises is that we've got a company 𝗵𝗲𝗁𝗃 who say, hey, our boilers are open therm. We've got a company Drayton who say, hey, our controls are open therm, and that someone should need to ask, because I know we've all been there. I mean, I always say this, I had an open therm 𝗵𝗲𝗁𝗃 and an open therm 𝗍𝗁 stat. And the first time I put them together, we do a lot of caravans around here, and there's an LPG one, and I thought, right, I'll get a good deal for the caravanners over there, try and keep, you know, energy costs down. And I put my heart and soul into trying to get these two to be compatible. I used, and Richard was talking about the open therm monitor. I've got one of those. You can buy them from Richard, about 100 quid, 120 quid something. But
gone up sadly, mate. But yeah, you know.
I haven't said that. I bought mine about 10 years ago, didn't I?
Gone up since 10 years ago, Kimbo.
But certainly there was communication going backwards and forwards. Now I don't understand it like Richard does, but I can recognise some of it. You can actually recognise. It's like when you're looking at computer gobbledygook. Every now and again you see a word that you recognise. And you think, oh, must be doing that then. But I was unable to, even though I had both 𝗍𝗁 and 𝗵𝗲𝗁𝗃 promising me that it wasn't their fault. No way on God's earth would this boiler communicate properly with open therm, and that's really sad. And I think Drayton's quite fortunate that we've got Richard on board with them, because I've been trying as best I can to try various things with various different boilers, which is a bit difficult these days because I've retired. But I've got my gang up here in Northampton, and I tweak their arm. Can you try one of these with one of those? And if you get a problem, give me a shout, and I'll come over. And then we've got Richard who can actually, you know, put them on his test rig and actually read all this stuff and see what's going on. And I know sometimes, you know, Richard will say, well, the reason, for example, let me think, the reason that you can't set the control on the 𝗵𝗲𝗁𝗁𝗃 with this particular open thermostat is because there isn't some, I don't know, protocol or some code written in, so on and so forth. Now, 99% of us, 99.9% of us are never, ever going to understand open therm to that degree. We don't need to, but it would be nice if all the manufacturers and all the controls people would get together and say, right, guys, you know, we've got an energy crisis. Let's instead of being independent, let's try and make this work. Let's all, I don't know, let's all give Richard a boiler, or let's all give Nesta a boiler. Let's everyone give Nesta their room stats and a few quid, and let's see what works. Let's get it all to work. So you can just buy this. If it says it's open therm, it's going to mean it's open therm, because it certainly doesn't at the moment, which is really quite sad.
Well, the key thing that happened actually is that off the back of myself and a few other of us moaning about the open therm issues to the Open Therm Association, was that they actually launched a test tool, which then the problem is that the test tool is still in-house regulated. Okay, so you get the test tool and you test your own open therm product, yeah. But the problem is that the open therm control IDs still aren't standardized across the board. Okay, so the control, what Kim was talking about earlier, is what we call control IDs, and the control IDs basically say I can control hot water, or I can control the maximum flow temperature, or I can control solar, you know, because open therm, believe it or not, can do solar control as well. You know, I mean, a lot of people say, oh, you know, the open therm system and the open therm, you know, control IDs can't do as much as 𝗵𝗲𝗻𝗃 or Valiant's closed systems, but it can. It's just the fact no one does. Yeah, it's got everything there and it can do everything, but you know, the manufacturer has the option to enable or disable these functions. And the problem is if you've got a boiler like 𝗵𝗲𝗁𝗍, and 𝗵𝗍𝗁𝗍 have made that boiler require a hot water demand. Okay, so they've required the thermostat to give that boiler a hot water temperature set point. Okay, and if the controls can't give that boiler a hot water temperature set point, it doesn't work with it. Okay, it just won't work with it. And the problem is that then 𝗵𝗍𝗁𝗍 go, oh well, those controls are crap, they don't work with it. It's not the fact they're crap. The controls don't require that open therm control ID. Okay, so the Open Therm Association have what they call core IDs, which I think it's about 11 core IDs that the controls must have and the boiler must have. Okay, but outside of that, it's free for all. You do what you want to do. You can, but what's meant to happen is if the control doesn't have those control IDs, the boiler is supposed, or it's not legislated that the boiler is supposed to have it, but the boiler should have it. Yeah. So if the thermostat can't control domestic hot water temperature, okay, for a combi, then the boiler's meant to be able to control the domestic hot water temperature. Not that if the controls are attached to it, oh sorry, we don't control that. The controls have got to do it. But no. The controls aren't meant to do it. It's an option. If they can do it, then great, they can control your hot water temperature. But if not, your boiler should be controlling that hot water temperature. But 𝗵𝗍𝗁𝗍 have made it that if the controls can't do hot water temperature control, they don't work with it. Yeah, and it locks out all the fascia. So as soon as you attach an open therm control onto that boiler, it locks out all the fascia, so you can't even adjust it. And it's the same on the Ideal Logic. You can't adjust it. And it's the same on the 𝗵𝗲𝗻. There was loads of others, and it was almost like 𝗵𝗲𝗻, Ideal, 𝗵𝗲𝗁 decided, you know what, if you're not using our controls, other controls don't work. But then the problem is, poor old installer goes out to the boiler with an open therm, like Kim said, an open therm control, open therm boiler, should be able to do that with it, but it doesn't work. And then you've got guys then, sorry, I'm not reading it.
No, just like what Chris has said, you know, if he'd known 𝗻𝗁𝗍 didn't work with 𝗵𝗍𝗁𝗍, he wouldn't have bought the product. I don't know whether he means the 𝗵𝗍𝗁𝗍 or the 𝗻𝗁𝗍, but
yeah,
either way.
Don't buy the 𝗵𝗍𝗁𝗍. Yeah, don't buy the 𝗵𝗍𝗁𝗍, because ultimately, I mean the reason
protocol doesn't mean open protocol, does it?
Yeah, the open protocol thing is open as long as everyone talks to each other, like Kim says. Yeah. If everyone doesn't talk to each other, and boiler manufacturers go out of their way, which they have done, because I've looked at the open therm protocol. I know most of it. I know what I'm looking for when I'm looking for the controls. And the boiler manufacturers have intently gone out of their way to make their open therm control the only one that will work with it, unless that specific control has those additional control IDs. And that's the issue. So my advice is don't buy the 𝗵𝗍𝗁𝗍, don't buy the Ideal, force these companies to have those IDs in place. Otherwise, don't buy them. Buy an Intergas, buy an Alpha, buy the 𝗍𝗲𝗻 have sorted now. I think the 050 and the 100 series, they're sorted on that side now. So buy them. Don't buy the ones that don't work, because ultimately, when they're not, because problem is that while we carry on buying those boilers, these manufacturers just keep slinging them out the door. They don't care. The second they stop getting bought, they will have to do something about it. You know, why? Well, you know, sales rep down at 𝗵𝗲𝗁𝗁 or wherever the hell you are. Why is the Ideals not selling as well? Oh, I don't know. They've just gone over onto Alpha. You know, and then they'll get back to the point at which they'll find out, and they'll go, oh, okay, well, yeah, well, we're not buying. Oh, well, I'll talk to an installer. Why aren't you buying our boilers anymore? Oh, it's because it don't work on OpenTherm. I want to fit 𝗺𝗲𝗁𝗁𝗁𝗁 controls, or I want to fit this, or I want to fit that, and it doesn't work with it. That's why I've stopped buying it. And they would have to instantly and overnight do something about it. But while it all goes on, nothing gets done, because you know I've been more than frustrated with the OpenTherm Association, and the reason being is because they just sit back, take the money, don't do a lot about it, you know. But if the OpenTherm Association turned around to its members and said, look, these are the core IDs, all these appliances now are going to have to do them. If they don't do them, then you can't be part of the OpenTherm Association anymore. You know, and everyone would change overnight. It's a bit like everything, isn't it? You know, if something's legislated by a body, people will make that change. If it's not legislated, everyone just carry on what they're doing all the time. You know, and that's really sad. You know, so it's only really, the emphasis is on really the manufacturers to do the right thing. But you know, how many manufacturers are doing the right thing? There's not many. I think I look out there's a handful. And you know, the problem is when you do that, if you don't do the right thing, especially when it comes to the OpenTherm protocol, you just get things that don't work with each other. And then, you know, I can understand why people just go, you know what, don't bother with all these smart controls and everything else, just do weather compensation. And it's that that's caused it. And 𝗍𝗲𝗁𝗁𝗁𝗁 and Ideal have been two of the biggest culprits for that in causing the issues with the OpenTherm connection. And it's really sad, because there's absolutely no, if they've just got those bits right, none of this would have happened, and none of these issues would have existed. And it's just such a shame. But I don't know. I can't say any more than that, really.
I could.
You know?
Well,
well, we need to, you know, it needs to change, doesn't it? And you know, like you said, Richard, it's like the installers are kind of part of the solution, aren't they? You know, I'm as Drayton, I can't say boycott this boiler, boycott that boiler, but you know, if you stop buying something that doesn't work as you want it to work, then they're gonna at some point make that change so that it does become more open. And that's the it's got to go that way. Surely that's the way it's got to go.
If you put up with something, it's like anything, isn't it? You know, we always say this in this country, don't we? We're quite toothless as far as a country. We're quite toothless. Like the fuel prices and stuff in other countries have resulted in riots and, you know, lobbying and everything else. In this country, what have we done? We've just sat back, paid it. Nothing's really happened much, is it? Do you know what I mean? It's a bit like that with everything that goes on with the boilers. You go out, you fit the boiler, you do the OpenTherm thing. Oh, it doesn't work. Okay, well, I'll just stick it on off. Okay, it works. Customer pays. Off you go. The only time the customer's not going to pay, obviously, is if you've gone out and said, right, I'm going to fit you an OpenTherm control to an OpenTherm boiler. You do that, and they go, why have you fitted that on off, mate? Well, it didn't work. I'm going to be really honest with you. It didn't work, actually. What was happening is the boiler was going to 1,000,000 degrees Celsius, and I lost all the hot water control. And they'll go, well, I wanted OpenTherm, you know, and that's who's liable then, because ultimately 𝗍𝗲𝗁𝗁𝗁𝗁 are liable, or Ideal are liable for that. So then, okay, we're really sorry, but go back to Ideal or 𝗍𝗲𝗁𝗁𝗁𝗁, but then you don't get paid. It's kind of one of those things, and 𝗍𝗲𝗁𝗁𝗁𝗁 or Ideal have caused the issues for you then. Do you know what I mean? Because of the way they've done things, and it's nuts, really, when I think about it. But you think, you know, I'm just talking about like Intergas boilers, and this is why I like Intergas. Like their OpenTherm protocol is like 20 years old. Do you know what I mean? These things were condensing in the 80s. Their OpenTherm protocol's 20 years old, and it's seamless. You know, it works. That's why I said to Drayton, because Drayton have got Intergas that they test with their OpenTherm controls. The first thing I said is throw them all away, get the worst OpenTherm boilers in the world in you can imagine, because those are the ones you learn off. Those are the ones you go, you know what, this is really terrible. We need to make our controls be able to control something terrible, you know, and that should never be the case. It should always be the case that you buy the best boiler in open therm wise. I'm not saying necessarily that is the best boiler out there, but on the open therm connection, it definitely is the best boiler out there, you know, and that's half the problem. When I first started doing my tests with open therm, I had an intergas boiler, and when everyone else started going, oh, you know, I've got these problems here, there, and everywhere, I started going, well, I don't know what you're talking about. It works perfectly on this. And then then like the penny moment drops, and you go, shit, actually, is the open therm protocol not the same on this boiler as it is all the others? And then you go and research it a bit, and you go, actually, it's not. And because 𝗵𝗲𝗁𝗍 have wrote it, or Ideal have wrote the protocol in how they think it should run, you know, and that's never a great step, you know. It should have always been the open therm part of it was closed, and the manufacturer had to integrate their bits with the open therm protocol, and that's how it should have worked. But ultimately, the manufacturer's allowed to do what the hell they want with the protocol, and that's when it's gone wrong, you know. So that's you know, yeah. Go on, Claire.
Go on. There's a couple of questions. Couple of questions. We're already on 1 hour and 5 minutes, but that's all good. Everybody's still watching. So Gaz Warnes has said, what boiler manufacturer have you found is the best for open therm and wiser?
Intergas.
Intergas.
I think we can gather it's Intergas.
Intergas or Alpha. I've been doing some Alpha testing. Its open therm protocol is really good. So yeah, Intergas or Alpha. 𝗵𝗲𝗁𝗍𝗁 are very good as well. So you know, the problem with the 𝗵𝗲𝗁, the old 𝗵𝗲𝗁, so the old 050s and the 100 series, is you couldn't, when you put an open therm controller onto it, you couldn't adjust the maximum flow temperature. I've got to test a bit more, but I'm led to believe by a few of the installers that that's possible now. So, you know, stick with those. I mean, some people, I mean, I don't do 𝗵𝗲𝗁𝗍𝗁 because they don't sell to independent merchants, but 𝗵𝗲𝗁𝗍𝗁 are also very good on open therm. So, but you know, two of the biggest boiler manufacturers in the UK, you know, Ideal and 𝗵𝗲𝗁𝗍𝗁 they've got a lot of accountability, to be quite frank. So
and then one last one before we wrap up from Martin. How are we supposed to know if the open therm is actually working?
Can I have a punt at that one?
Yeah, go on.
I'll have a punt at that one. So the way I with Richard will correct me on some of this because they probably don't all work the same way, but you got this thing when you put your set point in your room, let's say it's 21 degrees, the boiler it won't race away, but the boiler will race away up to its predetermined maximum flow temperature to achieve that. But as it gets close to the set point, okay, there's something there called a bandwidth, and it's somewhere between 1 and 2 degrees. So if you've got a set point of about 21 degrees, somewhere about 19 and a half degrees, and you can watch it on the room stat, you'll see or feel or hear the boiler start to modulate down. And that was a simple way that I used to make sure that when I was fitting open therm controls on open therm boilers, that everything, well, not maybe everything, but at least definitely open therm was in control. I don't know what, I mean, Richard would probably go down a far more technical route than that, but if you and he may have some comments on that as well, but that's how I would check it. And then I would turn the temperature down, and you could hear the boiler modulate down, turn the temperature right up by perhaps 5 or 6 degrees, so it's moved right away from that sort of 1.5 degrees bandwidth, and you could hear the boiler sort of take a sigh of relief, and it would ramp up to its maximum temperature again to get there, and again it'd get to the new bandwidth at perhaps 23 degrees, and then it would start to modulate down again. So that I think is a sort of an on-site, not a layman's, but an on-site engineer's way of just making sure that at least there is some open therm communication. And then, of course, you've got to hope that the rest of it's going to work. Certainly with an Intergas, which again was my boiler of choice, completely independent of Richard. We both came to conclude we didn't even met each other. In fact, we met each other because we were both using the Intergas boiler. So we both came to the same conclusion on that. And I'm a big fan of Alphas as well. So I don't know if you've got any comments on that, Rich, but that's how I've.
Yeah, I mean, yeah, I mean, Kim's spot on. So if you put a big demand on the thermostat, the boiler will ramp right up to its maximum set point, and you predetermine that. On the good boilers, you can set that. So you know, on good controls, you can set that as well. So some of the controls will actually allow you to set the maximum flow temperature, but if the controls don't, then the boiler really should. Okay. So I'm referencing Intergas again. What you can do on the Intergas, you set the maximum flow temp. So say that was 70 degrees, for instance. If you were to ramp the thermostat temperature right up, it would be at 70-degree flow temperature. And then if you were then to actually set the thermostat down to actual room temperature, so if you set the demand to the actual room temperature like that, then what you would expect to see is the actual flow temperature of the boiler actually reduce. And it would reduce, you know, it might drop to 50 degrees, 40 degrees, whatever that might be. But you should definitely expect to see that level of modulation, and that will happen with open therm controls. To do a basic test to see if it's actually working, all you need to do is actually disconnect the wires off the receiver end of the, so say if you're using the 𝗵𝗲𝗺𝗏, if you actually disconnect the open therm wires off there and then touch them together, what you should see is the boiler actually come on and go to maximum. So that's how you test the open therm connection, or the wiring between the thermostat and the boilers correct, is just by touching them together. They're extra low voltage, so you're not going to get electrocuted or anything like that. But the open therm protocol is programs that if you touch the two wires together, the boiler will come on and go to its highest demand. So that's just a quick way of testing. But I mean, you always got to do best practice though, and some of the things that I used to cover on some of the open therm courses I did a couple of years, well, before pre-COVID lockdown actually, is I was doing a couple of days a week up at Intergas, and I was doing the training on the open therm. And one of the things to note there is just always run your open therm cables completely separate to your 230 volt, because a lot of people use 5-core cable. And that's the worst thing you can do, is use 5-core cable and use 2 of the strands in there for your open therm connection. You've really got to use a 2-core cable up to the open therm connection, and then a 3-core cable then onto your 230 volt connection completely separately. And that's really important. And you've got different bands as well. So on the electrical regs, you've got, I think it's a band 1 and a band 2. And you've got to keep those bands, so 230 volts away from voltages up to, I think it's 120 volts. You've got to keep them away from each other. So it's good practice to do that anyway. But if you do that, normally you won't have any open therm faults. But plenty of times I've seen people do it in 5-core and they've had open therm issues. So try not to do that. But yeah, that's open therm in a nutshell.
In a nutshell.
So,
well,
yeah.
Have a crack at the last one as well. The non-open therm.
Claire wants to go home.
No,
well, she's home.
I'm already home.
She's already home, but she wants to go and have a wine. Do you know what I mean?
No, I've already got wine. It's fine. I was just waiting.
All right.
Go on, Kimbo. What are you going to say?
Will the pump speed on auto will modulate the boiler? Okay, so the pump doesn't modulate the boiler modulates the pump. Okay, so the pump is normally tied in with the gas fan, and so as the fan, if you want, sucks in more gas, more kilowatts are going to be generated. So we need more flow. So we need more flow. We need more pump. So that's the automatic bit. The bit that we need to understand is that it comes out the box usually set to the highest pump that it can go. A lot of these systems, the index circuit, the highest resistance part of the circuit is actually very, very, very low. We have 6-7 meter head pumps quite often, lots of 22 and 15 mil small houses, three bed houses. We'll have an overall index circuit of about less than 2 meters. So if you've got a 6 meter pump, you're over pumping it massively, and that's what's going to cause the DT to collapse, and it's going to lift it away from condensing mode altogether. You have a flow and return temperature of about 10 or 12 maybe across the boiler, which is no good at all. This is why you have to set it to the index circuit first, then it's automatic. And again, coming back to the Drayton pressure independent valves, they say them automatic balancers, and they are, but they're only automatic after you've set them.
Yeah.
You know, you've got to work out the flow rate, set it, then they kick in and say, right, you can leave this to us guys. We'll sort this out from now on. So they are automatic.
And they're great, aren't they? I mean, just to emphasize how great they are on the Ideal and 𝗵𝗲𝗁𝗍 boilers. And the reason we say that is because those boilers, you can't adjust the pump speeds on. They're literally like the Ideal Logic as I think it's an 80% pump speed, and the Ideal 𝗶𝗀𝗺 is a 70% pump speed, but they won't come down from that. And that's too much. You know, on like the Intergas boiler, when I'm setting the pump up on that, we're down at like 35–40% pump speeds, you know, and that's all you need for quite a big system, you know, because like Kim said, it's all about the head pressure on the system, and we don't need 6 meters or 7. You know, these boilers have got like 7-meter head pumps in them. We don't need 7-meter head of, you know, you don't need that on a system. Obviously, you do lose a little bit of head pressure over the heat exchanger, but we don't lose that much. We lose a couple of meters head at best, you know, and you know, so that means then you've still got 5 meters ahead for your system, which you might only need a meter head or 2 meters head for, you know, and you don't need that much. And if you have that much pressure, it's going to whiz around that system, and like I said, these pumps need to be adjusted. If they can't be adjusted, the only way you're going to tackle those systems is with auto balancing TRVs. That's it. Right.
We've got one more to go, Claire. As a punter, how do you know the problem is with 𝗵𝗲𝗁𝗍 and not 𝗺𝗎𝗇? Where is the proof where the problem is?
It's in their manual. 𝗵𝗲𝗁𝗍 very clearly state in their manual that if your open therm controls do not have the hot water setting, that it won't work. And it's them that's caused that. Okay, so that hot water setting, what should happen is if the controls don't have it, so 𝗺𝗎𝗇 doesn't have it, there's loads of controls out there that don't have it, right? Or they don't have it at the moment. Because they don't have it, they don't work. But that's 𝗵𝗲𝗁𝗍 that's caused that. That's 𝗵𝗲𝗁𝗍 that if the controls don't have it, they haven't allowed their temperature dial then to be adjusted. That's 𝗵𝗲𝗁𝗍's issue, not the open therm's issue, you know, and that's what you need to realize. So, you know, it's like I said, it's these manufacturers building in these problems into the boilers to cause other controls on the market to have problems with their appliance. Because I think they've got their own control and it works fine with it, but it works fine because it's got those control IDs. So do you know what I mean? It's such a minefield. I do feel so sorry for the guys out there, but you know, ultimately what the third-party manufacturers are having to do is build all these IDs into their system, so they will work with any boiler. But the problem is that takes time because it's outside of the open therm scope. So you know, that's it in a nutshell. But it's in 𝗵𝗲𝗁𝗍's manual.
Time to go home, guys.
Thank you. So we're going to wrap up there. Thank you guys so much for this year, the whole year. You've been fabulous, and I can't wait to do more with you next year. And we're going to do loads of different stuff, talk about different things, and hopefully get some more education out there on these different ways of doing things to make systems more efficient. So that's it. Signing off for 2022. It's a bit early, but have a great Christmas.
The tree's up, so you know.
Perfect. See you all next year.
See you next year. Ta-ra.
Bye, everyone.